Okay, let's go ahead and solve for the transfer function of this RL circuit and determine whether it's a low pass filter or a high pass filter. And the transfer function h of omega in the frequency domain is also equated to V out of omega over Vs of omega. Now, there's many different ways to solve the circuit, but what I'm going to use is KVL, or Kirchhoff voltage law. And I'm going to say that I have a current, call this current I of t, flowing through my circuit, where it goes into the plus minus for the inductor and plus minus here for the resistor. Writing my KVL equation in the frequency domain, I'm going to say then that minus Vs of omega plus I of omega times j omega L plus V out of omega is equated to 0. This here I of omega can be rewritten using Ohm's law as V out of omega over R. So if I go ahead and plug that into I of omega here, I get minus Vs of omega plus V out of omega over R times j omega L plus V out of omega has to equate to 0. Let me go ahead and pull out V out of omega. I'm left with 1 plus j omega L over R has to equate to Vs of omega. I just moved this minus to the right-hand side. So now I'm left with my final answer, which is V out of omega over Vs of omega, which is also equals to h of omega as R over R plus j omega L. So if we plugged in omega equals 0 or a DC value, we would get R over R, which is 1. So that means that my low frequencies will pass through. And if we plugged in omega is infinity or a high frequency value, we would get R over infinity, which is 0. So that means my high frequencies do not pass through. As a result, this here is a low pass filter. Thank you.